Today's lesson is on chapter 3.2, Introduction to Exponents, as well as 3.3, Exponent Laws. Let's start with 3.2. A variable is a quantity whose value can change. Usually a variable is a letter of the alphabet, usually lowercase. The most common variables that we use are x, y, a, and b. An algebraic expression is a mathematical phrase made up of numbers and variables connected by addition or subtraction operators. For example, 3x subtract 4, 5x squared plus 3, 7x squared minus 2x plus 4. It's important to note the difference between an expression and an equation. The difference is the equal sign. An equation has an equal sign that separates an expression on the left side and an expression on the right side of it. So if you see that equal sign separating the left and the right side, then that's an equation. If there is no equal sign, then it's an expression. Let's label the variables, expressions, and equations in this example. So the variables are x and x. The expressions are the left side separately and the right side separately. The entire sentence is an algebraic equation. A power is a product of identical factors and consists of two parts, a base and an exponent. In this example, the 2 is the base. It's the big number. The little number in the top right-hand corner is called an exponent. Combined, the base and the exponent we call a power. The base is the identical factor, and the exponent tells us how many factors there are. In this example, the exponent 3 is telling us that we're going to multiply the base 2 by itself 3 times. Let's practice evaluating powers. What we're going to do is we're going to expand the power first and then evaluate. 2 to the power of 5. That is 2 times 2 times 2 times 2 times 2. 5 times. And using your calculator, that's equal to 32. In B, we have -3 in brackets. These brackets tell us that everything inside of the brackets is the base. So we're raising -3 to itself 3 times. So this is -3 times -3 times -3, which is equal to -27. So using my calculator, I'm going to make sure that when I type in -3 to the power of 3, I'm including those brackets. If I just type in -3 to the power of 3 in my calculator, you're going to get a different answer. You want to make sure that you write bracket -3, close bracket, and then exponent 3. Okay, and in C, again, we have brackets. So the negative is included in our base. We're going to multiply -3 by itself 4 times, which is equal to 81. D, this time there is a negative, but it's not in the brackets. So that means that the negative is not part of the base. So really this says negative times base 3 exponent 4. So this is saying that it's going to be base 3 times itself 4 times with a negative in front of it. So -3 times 3 times 3 times 3. So 3 times 3 times 3 times 3 is equal to 81. and then we'll have a negative in front of it. Next, E. This is a decimal number. The entire decimal number is part of the base. 3.5 times 3.5 times 3.5, which is equal to 42.875. In F, we have a fraction. The entire fraction will be multiplied by itself 3 times. Okay, and remember when you're multiplying fractions, you multiply the numerators together and then the denominators together. So 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. Okay, in example 2, it's asking us just to evaluate. So we don't need to expand. We can just solve. So in your calculator, you're going to type in exactly what you see. Bracket -5 close bracket to the power of 3, which is equal to -125. In B, it's the same power minus the brackets. So in your calculator, you're going to type in -5 raised to 3, and you'll get -125. In C, we have brackets, so our negative is part of the base. So in your calculator, make sure you're including the brackets. You're going to get +625. And in D, without the brackets, the negative is not part of the base. So your answer is going to be -625. Brackets are very important. Please make sure that you're typing them into your calculator. These brackets are changing the base. Okay, so in part A, the base is -5. So really it's -5 times -5 times -5. In B, this is really -5 times 5 times 5. So your base is just 5. In C, the negative is included in the base. So this is -5 times -5 times -5 times -5. And in D, the negative is not included in the base. And this is 5 times 5 times 5 times 5 with a negative in front of it. What's also important to note is the value of your exponent. If your exponent is an odd number, it doesn't matter if there's brackets or not, your answer is going to have a negative. If your exponent is an even number, the brackets will make a difference, whether or not your answer will be positive or negative. Okay, let's look at A and C. So in A, -5 times -5 times -5, they both have brackets. And this one is -5 times -5 times -5 times -5. Okay, but one is an odd number of times that you're multiplying -5 by itself, and one is an even number of times. So really, this is negative times a negative will make a positive, and then positive times the last negative here will end with a negative. But in C, these two negatives will make a positive, these two negatives will make a positive, and these two positives will end in a positive value. So not only do brackets alter your base value, the exponent being an odd or even number will also alter whether or not your answer is positive or negative. For the last question, E, we have a value in front of the base. We call this a coefficient. So this coefficient is going to be multiplied by the base. It is not part of the base. Following our BEDMAS rules, I'm going to simplify my exponents first. So my first line, I'm going to leave for the coefficient as is, and I'm going to multiply -3 times itself 3 times. So -3 to the power of 3 is -27. And then my next line, I will multiply that by the coefficient 4. Next, we are going to evaluate expressions by substituting given values. We have a value of -6 for b. So wherever I see variable b, I'm going to substitute -6. And then h has a value of 3. Variable h will be substituted with value 3. So my next line is -6 squared times 3, subtract 3 times -6. Following the order of operations, I'm going to simplify -6 squared before multiplying it by 3. Three times -6 is -18. 36 times 3 is 108. Negative and negative make a positive, 18. Next question. R has a value of 4, and H has a value of 10. There is a pi sign here, which has a value of 3.14. In high school, we no longer type in our calculator 3.14. We use scientific calculators and they all have the pi button. And so you're going to click on that instead of typing 3.14 in your calculator. It does make a difference with your final answer and rounding. The question is 1/3 times pi times r squared times h. So this could also be written as 1/3 times pi times r squared times h, which could also be written as 1/3 times pi over 1 times r squared over 1 times h over 1. Every whole value has an invisible denominator of 1. We just don't include it, but it's there. Now, since our first value, 1/3, is a fraction, I'm going to include the denominator of 1 to create fractions for all of our values. Now that all of my values are fractions, it's easy for us to multiply the numerators together and then the denominators. Okay, so I'm going to multiply my numerators together. 1 times pi times r squared times h, which is equal to pi times r squared times h. I'm just going to eliminate the 1. We don't need to include it. Next, we're going to multiply all of our denominator values together. 3 times 1 times 1 times 1 is 3. So another way of writing part B, the expression that is provided to us, is pi times r squared times h all over 3. I'm going to now use this new expression in my next line while I substitute the values provided. Pi times 4 squared times 10 all over 3 is equal to pi times 16 times 10 divided by 3 is equal to, now I'm going to multiply my entire numerator together. So pi times 16 times 10 is equal to approximately, that dot on top of the equal sign means approximately 502.65 divided by 3, which is equal to approximately 107.55. Now, when I'm rounding, I'm going to include this approximate sign. Let's practice a word problem. Joe thinks that negative 4 cubed is equal to 12. Is he right or is he wrong? Joe is wrong. The negative is not part of the base. So really this is negative 4 times 4 times 4. Additionally, I think that Joe is getting confused. He's reading this as 4 times 3, which is not correct. This is not multiplication. This is exponential. So it's not 4 times 3, it's 4 times itself 3 times. There are some questions for you to try in the textbook in 3.2. I suggest that you practice 3.2 textbook questions before moving on to 3.3. You may pause the video now and complete these questions, and then resume watching 3.3. Chapter 3.3 is all about exponent laws. The exponent laws are a way to simplify expressions involving powers with the same base. All of these powers have the same base. 3 and 3, 6 and 6, 2, 2, 2, k and k. And we are multiplying these powers with the same bases together. Remember, in math, product means multiplication. Let's investigate what happens when the powers with the same bases are multiplied together. So 3 to the power of 3. We can expand that to 3 times 3 times 3. Now we're multiplying that by 3 raised to 5. 3 times itself 5 times. So really, as a single power, the base is 3, and we're multiplying itself by 1, 2, 3, 4, 5, 6, 7, 8 times. 3 raised to 8. So how do we get from the product of two powers with the same base to a single power without expanding? Well, we kept the base the same. What we've done is we've taken the two exponents and we've added them to get the single power of the product of two powers with the same base. Let's practice again with example 2. 6 raised to 5 is 6 times itself 5 times. And then we're going to multiply that by 6 times itself once. There is an invisible exponent 1 here. When you see a value without an exponent, there is an invisible exponent of 1. We just don't write it. So 6 times 6 times 6 times 6 times 6 times 6, that's 6 times itself 6 times. Okay, so the base will remain as 6. And we're raising it to itself 6 times. Next, 2 to the power of 6 is 2 times 2 times 2 times 2 times 2 times 2 times 2 squared times 2 times 2 times 2 cubed times 2 times 2 times 2. So as a single power, that is 2 to the power of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Or 6 plus 2 plus 3 is equal to 11. And finally, instead of using integers, we're using variables. K cubed times k to the power of 5. So that's k times 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 k, which is equal to k. 3 plus 5 is 8. So to summarize exponent law, a product of a power, when multiplying powers with the same base, keep the base the same and add the exponents to write the product as a single power. So x raised to a times x raised to b, we're going to keep the base as x and add a and b. So this is the first exponent law. We call it product of a power. Let's apply this exponent law to an example. Write each product as a single power, then evaluate the power. 3 squared times 3 cubed. So again, we're going to leave the base the same and then add the exponents. And then it tells us to evaluate the power, which means that we're going to type this into our calculator. 3 to the power of 5 is 243. B, 5 squared times 5 times 5 squared. So remember, there is an invisible exponent 1 here. So I'm going to leave the base the same and add my exponents. 2 plus 1 plus 2 is 5. And then I'm going to evaluate 3,125. C, negative 2 to the power of 4 times negative 2 to the power of 3. So my base is negative 2. 4 plus 3 is 7. Now in my calculator, I'm going to type this all in, including brackets, negative 128. And finally, negative 4 to the power of 3 times negative 4 to the power of 2. So negative 4 is my base. 3 plus 2 is 5. And then typing that into my calculator, bracket negative 4 close bracket, exponent 5 is equal to negative 1,024. What if the powers were dividing now with the same base? So in the first example, 3 raised to 7 divided by 3 cubed. So that's 3 times 3 times 3, 7 times. 1, 2, 3, 4, 5, 6, 7. Divided by 3 times itself 3 times. So 3 divided by itself is equal to 1, or they cancel each other out. 3 divided by itself cancels itself out. One more time. So now I'm left with 3 times itself 4 times in the numerator. So I'm left with 3 times 3 times 3 times 3, which as a single power is 3 raised to 4, which is the same as keeping the base the same, and then subtracting the exponents. Let's practice again. So we have 7 raised to 4 divided by 7 with an invisible exponent 1. 7 times 7 times 7 times 7 divided by 7. These two 7s cancel out, so you're left with 7 times 7 times 7, which is the same as writing it as a single power 7 cubed. So 4 subtract 1 is equal to 3. So when we're multiplying bases that are the same, we are adding the exponents. And when we're dividing bases that are the same, we're subtracting the exponents. So the next one, we're going to cancel out as many as we can. And we're left with 1, 2 in the numerator. So as a single power, this is 2 to the power of 1, or just 2. Because remember, when your exponent is 1, we just don't include it. It's invisible. Let's complete the last example together. 5 raised to 4 divided by 5 raised to 4. 5 times 5 times 5 times 5 divided by 5 times 5 times 5 times 5. The numerators and denominators will cancel each other out. And so 5 divided by 5 is equal to 1. Writing that in a power is 5 raised to 0. When your exponent is 0, it'll always equal to 1. Okay, so when you get an answer of a base raised to exponent 0, you're going to simplify it to 1. Let's summarize our new exponent law, quotient of powers. Remember that quotient in math means division. Let's write that up here. When dividing powers with the same base, keep the base the same and subtract the exponents to write the quotient as a single power. So x raised to a divided by x raised to b. We're going to keep the base the same, and we're going to subtract the exponents. Let's practice using some examples. Write each quotient as a single power, then evaluate the power. Okay, so we're going to keep the base the same and subtract the exponents. 7 subtract 4 is 3. And then typing that into your calculator, 8 cubed is 512. Next, the base is the same, and we're going to subtract all of our exponents. And remember that this 4 has an invisible exponent 1. So 7 subtract 1 subtract 3 is 3. 4 cubed is 64. Next, we have the same base, negative 0.5. And then I'm going to subtract 2 from 5. And that is equal to negative 0.125. And finally, this is a 2-step answer. I'm going to simplify my numerator first and then divide it by my denominator. So in my numerator, it's 6 raised to 100 times 6 raised to 50. So the base is the same, and I'm going to add, because it's multiplication, I'm going to add my exponents. So that's 150. Then divided by 6 raised to 148. And now I'm going to divide. This is now a division question. So the base will be 6, and then 150 subtract 148 is 2. 6 squared is 36. Investigation 3. How can you simplify expressions involving powers of powers? So now we have one power inside the brackets and then one outside the brackets. Okay, so this is 5 to 3, 3 times, right? The brackets tell me that the base is 5 to the power of 3. And I'm going to multiply that by itself 3 times. Okay? And then 5 to the power of 3 is really 5 times 5 times 5. Okay? And then there's a second 5 cubed, which is another 5 times 5 times 5. And then the third 5 cubed is 5 times 5 times 5. As a single power, this is 5 to the power of 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Going back to my power of a power, 3 times 3 is equal to 9. So when you have a power raised to a power, you're going to multiply the exponents together to simplify it to a single power. Let's try the next one. So 10 raised to 4, and then that's raised to 2. So my base is 10 to the power of 4, multiplied by itself 2 times, which is equal to 10 times itself 4 times. And then that's multiplied by 10 times itself 4 times. So the base is the same, and the exponent is 4, 5, 6, 7, 8. Okay, so 4 times 2 is 8. And finally, variable a squared raised to 5. So that's a squared times a squared times a squared 5 times, which is equal to a times 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 a. So as a single power, it's a to the power of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Or what is 2 times 5? 10. So to summarize, when a power is raised to an exponent, keep the base the same and multiply the exponents to write as a single power. So x raised to a, all raised to b, is keeping the base the same as x raised to a times b. Let's practice. Write each as a single power, then evaluate the power. So the base will stay as 3, and we're going to multiply 2 times 4. And then using our calculator, 3 to the power of 8 is 6,561. Next, we have brackets inside of brackets. So the first bracket, the inner bracket is telling us, is indicating the base. The base is -2 raised to 3. The outer square brackets indicate that everything inside of it is a base that must be raised to 4. So I'm going to take my two exponents and I'm going to multiply them together. -2 in brackets raised to 12, which is equal to 4,096. See, my base is 5 raised to 4, which is equal to 625. And then D, my base is 0.2. 3 times 2 is 6, which is equal to 0.0000064. Power of a product. When 2 or more factors are raised to an exponent, each factor is raised to the exponent. So x and y are 2 different factors inside the bracket. We must raise x and y separately to a. Power of a quotient. When a quotient, or a fraction, remember fractions are division, is raised to an exponent, both numerator and denominator are raised to the exponent. So the exponent a, we must apply it to x and to y. Let's practice. 2/3 raised to 2 is the same as saying 2 raised to 2 over 3 raised to 2. 2 squared is 4, 3 squared is 9. In B, we have a negative and then a fraction. So that negative, we're going to keep it with the numerator. This is equal to -4 cubed divided by 5 cubed, which is equal to -64 divided by 125. Example 3. Simplify each algebraic expression by applying the exponent laws. So now all the exponent laws that we learned today, we're going to apply all of them to these examples. In part A, this is keeping the base the same, and then we're going to add the exponents. In B, we have to simplify the brackets here before we can multiply it towards any of the other terms. Now, all of these bases have a coefficient in front of them. The first one is 6, the next one is 3, the next one is 4. We're just going to either divide or multiply the coefficients together according to what the operation is, but the bases are still the same. We're still going to use the exponent laws towards those bases and its exponents. My first line, I'm going to simplify these two terms, and it's division. So I'm going to divide my coefficients 6 and 3. 6 divided by 3 is 2. My base is the same, and I'm going to subtract my exponents. Then I'm going to multiply that by the simplified term that's last written here. So before I can apply the coefficient 4, I have to simplify what's in brackets. So p to 4 raised to 2. So I'm going to multiply. This is the power of a power rule. So I'm going to multiply my exponents and keep my base the same. Next line, I'm going to multiply my coefficients together. And then I'm going to keep my base the same and add my exponents. C, 3 times 2x squared y, all raised to 3. So this exponent 3 must be applied to all the factors inside the brackets. So we're going to raise 2x squared and y to 3. So we're going to leave the coefficient as it is for now, and we're going to apply the exponent 3 to all the factors inside the bracket. 2 times 3 is 6. I'm going to simplify 2 cubed to 8. Next line, I'm going to multiply coefficient 3 by coefficient 8. And that's my final answer. I can't simplify it any further because we don't have any bases that are the same that are left. Next, I'm going to apply the exponent 2 to all the factors inside the bracket. 3, a raised to 4, b raised to 3. 4 times 2 is 8. 3 times 2 is 6. 3 squared is 9. And I cannot simplify any further. So remember to simplify separately your numerator and denominator. In my numerator, I have 2 coefficients that I'm going to multiply together. Then I have 2 bases that are the same, so I'm going to add those exponents. And I also have 2 bases that are the same, so I'm going to add those exponents. In the denominator, I'm going to multiply my coefficients together. 5, and there's an invisible coefficient of 1. Then I have my a powers that I'm going to simplify together, and then my b powers that I'm going to simplify together. Okay, let's put this together. Coefficient 3 times coefficient 10 is 30. A squared times a to the power of 6. I'm going to keep the base the same and add my exponents. B to the power of 5 times b to the power of 10. I'm going to keep my base the same and add my exponents. That will be divided by 5 times 1, my coefficients. A has an invisible exponent of 1. So I'm going to keep the base the same and add my exponents 1 and 2, which is 3. And then b squared times b to the power of 4. I'm going to keep the base the same and add my exponents. And finally, I'm going to simplify the numerator and denominator together. So I'm going to divide my coefficients 3 divided by 50. And then I'm going to divide my powers of A, keep the base the same, and subtract my exponents. And then divide my powers of B. Keep the base the same and subtract my exponents. Finally, letter F. I'm going to simplify my numerator first, and I'm going to simplify my denominator separately first, and then I can simplify the numerator and denominator together. My coefficients, I'm going to multiply them together. My powers of U, I'm going to keep the base the same and add my exponents. For my V powers, I'm going to keep the base the same and add my exponents. In the denominator, I'm going to apply exponent 2 to all the factors inside the bracket. 4 squared, U squared, V, 2 times 2 is 4, which is equal to negative 16 U 9 V 5 divided by 4 squared is 16 U squared V raised to 4. Now that I've simplified my numerator and denominator separately, I can now divide my denominator by the numerator. Starting with the coefficients, negative 16 divided by 16 will equal to negative 1. U to the power of 9 divided by U to the power of 2. I'm going to keep the base the same, and I'm going to subtract my exponents. V to the power of 5 divided by V to the power of 4. I'm going to keep my base the same and subtract my exponents. We're almost done. We're just going to simplify this a little bit further. Remember, when your coefficient is 1, you do not need to include it. And when you have an exponent of 1, you do not need to include it. So I can simplify this to negative U to the power of 7 V. And that's it. Last question. Using your simplified algebraic expression from question 3F, substitute U equals negative 2 and V equals 1, and then evaluate. So our final simplified algebraic expression for question 3F was negative U 7V. So I'm going to substitute negative 2 in for U and 1 for V. So I'm going to keep my negative here for now, and I'm going to, in my calculator, I'm going to raise negative 2 to 7, and that's negative 128. And I don't actually need to multiply it by 1. I can just omit it at this point because anything times 1 is always the original number. And now I'm going to simplify my two negatives to a positive. And I don't need to write the positive, so I'm just going to write 128. There are some homework questions here at the bottom for you to complete for chapter 3.3. This is to consolidate your learning for chapter 3.3. Don't forget to complete today's quiz. Please join the Zoom or email or message me if you have any questions. Great job on getting through today's lengthy lesson.